If you take a quick look around your home and examine the items we use daily, you will notice that most of them have an expiration date. Whether it is food, beverages, or personal care products, all of these items will eventually expire, either becoming harmful or completely useless and inert. This shelf life varies from one product to another based on several factors, such as the nature of the product, how it is stored, or the storage environment. Although almost no product is without an expiration date, most of us only bother to check it on food, drinks, or medications because we fear getting poisoned. This begs the question, does poison itself have an expiration date like other products? And if it does, once that date passes, does it become more toxic, or does it lose its potency? To answer this question, we first need to specify exactly which poison we are talking about. If we look up the definition of poison, we find that the general concept is incredibly broad. Poison is any element or compound capable of causing damage to living tissue. This damage results from a series of chemical reactions that occur after the toxic substance enters the body, whether through ingestion, injection, inhalation, or skin contact. Toxic elements can be either synthetic or natural. Given this vast definition, we cannot speak of poison as a single substance or limit our scope to mouse poison, for example. The subject is far more complex than that. The dose makes the poison. If we go back in time, we see that humans have discovered hundreds of types of poisons throughout history, with new ones being identified in every era. Due to this immense diversity, the Swiss physician Paracelsus, who lived in the early 16th century and dedicated his entire life to studying toxicology, famously concluded, "All things are poison, and nothing is without poison. Only the dose makes a thing not a poison." As strange as this statement may sound, science has proven it 100% correct over time. Take the one substance we cannot live without, water. This principle applies to water as well. People can actually suffer from water intoxication if they drink it in massive quantities that far exceed the body's capacity. From this foundation, an entire branch of science emerged to study poisons, toxicology. This science categorizes poisons into different groups. One classification divides them by context into pharmaceutical, food, or neurotoxins. Another classification is based on the chemical state of the matter, which includes 4 types: gas, solid, liquid, and vapor. Poisons are also classified by their origin, such as plant-based, animal-derived, or synthetic. To put this into perspective, in the animal kingdom alone, there are over 220,000 types of venom. Currently, the most widely studied venoms in the world are those of snakes, spiders, and scorpions. Organic poisons and the famous snake experiment. The purpose of all this is to understand just how broad the word poison is. To answer our main question, we must isolate the specific type. Let's start with the most famous of all, snake venom. In a famous experiment, scientist Albert Calmette harvested venom from 3 different types of desert snakes: Cerastes cerastes, horned viper; Naja, cobra; Eryx jaculus, javelin sand boa. He took their complex venom secretions, drew a blood sample from his own body, and mixed the venom with the blood in test tubes. Moments later, without even using a microscope, he observed with the naked eye that each venom had a completely different effect. The venom of Cerastes cerastes caused the blood to clot. The venom of Eryx jaculus thinned the blood. The venom of Naja had no effect on blood density at all. This shows that even venom extracted from the same class of toxic animals varies wildly from one species to another, with each containing hundreds of different compounds, elements, and enzymes. The key takeaway here is that all poisons extracted from animals and plants are classified as organic poisons. This type of poison breaks down over time, meaning it has a definitive shelf life. Once this period passes, the poison loses its potency. inorganic poisons and the concept of half-life. Does this rule apply to all types of poisons? What causes organic poisons to degrade over time is that their compounds contain carbon and hydrogen atoms, which typically form weak bonds that break down easily. However, other types of poisons do not contain carbon and hydrogen atoms together. These are called inorganic poisons. If we look at elements like lead or arsenic, which are highly toxic, we find that in their inorganic form they do not degrade at all. But does that mean they don't have an expiration date? The answer is both yes and no. Lead and arsenic are elements that exist naturally in the Earth's crust, and they do not decompose in the traditional sense. Instead, they are governed by a concept called half-life, the time required for half of the substance's atoms to decay. This means their potency does not weaken, rather their total quantity or volume decreases. For example, lead-210, an isotope of lead, has a half-life of about 22 years. If you put 10 grams of it in a test tube, after 22 years, half of it, 5 grams, will decay and turn into a different element. Meanwhile, the remaining 5 grams will stay pure lead, retaining 100% of its toxic properties. However, if these same elements are synthesized into organic compounds, the principle of degradation applies, and their toxicity will decrease over time. When expiration makes it deadlier. Finally, there are poisons that have a stated expiration date, but once that date passes, their effect does not decrease. It does the exact opposite. We see this most often in synthetic poisons. Take agricultural pesticides as an example. They are manufactured to eliminate agricultural pests, but manufacturers place an expiration date on the packaging. Michigan State University warns against using pesticides more than 2 years after opening the container. It turns out that once these pesticides expire, they may lose their ability to kill pests, but their chemical compounds break down and transform into substances that are far more toxic and hazardous to both the environment and humans. Therefore, some poisons become more dangerous after they expire. This does not just apply to pesticides, it includes many human medications as well. Surprisingly, many drugs meant to heal us contain toxic compounds. When certain medications expire, they can react or decompose into highly toxic compounds that can severely damage the kidneys or liver. These specific chemical reactions cannot always be predicted as they vary depending on the drug itself. Conclusion: poisons are not all created equal. When their expiration dates pass, some poisons lose their potency, others become violently toxic, and some remain entirely unaffected by the passage of time.